Okay, on this for this problem, we're going to try to find the following value cosine 34 degrees. And all we're doing is actually just filling in the blank. We're not going to actually find a value, but we're supposed to use that cosine of theta is equal to sine of 90 degrees minus theta. But we also, all right, so let's just go ahead and do that. So this is simply, I put in 90 degrees minus 34 degrees. And so then that becomes an issue of whether I can subtract. And so maybe I can't. Okay, but I think I did in my head. But let me double check, which is sort of silly, but still. There we go. And then over here, tangent of theta is equal to cotangent 90 degrees minus theta. So, I mean, the pattern is you just take any of the trig functions and it's, say, tangent theta, it's equal to its cofunction. Cofunction of tangent is cotangent. And then we write, instead of theta, 90 degrees minus theta. So this will be 90 degrees minus 27 degrees. And so therefore that's, I believe, 63 degrees. Right? Okay, so we get that. Let's pull out the highlighter and go for that. Okay, and then over here, the same deal. 90 degrees minus 27 degrees. So, oh, it's the same problem twice, so that's just a typo. So let's just cut that out and not do that. And, okay, probably didn't need nearly as much space as I allowed here. So for secant, we have, well, secant theta is its cofunction, cosecant 90 degrees minus theta. And so we'll get 90 degrees minus 53 degrees. So that makes cosecant, okay, so isn't that 37 degrees? It's probably one of my weakest things is adding numbers in my head. Okay, but I think that's it. All right, and well, that's that video. It's a little bit short. Maybe I can just coast on to the next video. Didn't seem like enough to be in one video. Let's go to the next problem. I'll just push this up here onto this page. Okay, find the lengths of the missing sides where A is the opposite angle of angle A, side B is the opposite of B, and side C is the hypotenuse. Show all your work, including the drawing and labeling of a right angle. Well, this might be stepping up to something more difficult for sure. So let's just draw a right triangle. And I might shorten or lengthen these sides, but the idea is that, say we have A over here, B and C. Now, so sine B is equal to opposite over hypotenuse, and that's going to be 5 over 13. So what I can do is I can make like a little tiny triangle here where I make, okay, this is B, and I make, I should say, I think the dimensions are going to be a little bit more like, actually even more so, but it's going to be opposite of B is 5 and the hypotenuse 13. So this is a different triangle, but I don't know, I'll put it like B dash. Here's A dash and C dash like this. Okay. And see what I can do is on this triangle here, I have, this is little a. I have, or a, well, let's do it like this. I have a, just call this a squared plus b squared is equal to c squared. So I'm going to have a squared plus 5 squared is equal to 13 squared. Well, this is a Pythagorean triple, so in fact, you can just do it that way to see what these values are. I need more space, and I really didn't need to. I'll just move this down here. Sort of feel like I'm not doing this the most efficient way, though. But, okay. All right, let's move this down. Okay, so I have a squared equals 169 minus 25. A squared is equal to 144, and so a is equal to 12. Now, on the circle, on this guy over here, these really, when I say A, B, what I mean is little a prime, b prime, like that. On my real triangle, which is bigger, and also, again, will, as we see, won't have that shape, I have this other triangle that has the same proportions. It's proportional to this triangle, but on this case, opposite capital B is 10. And so what do I conclude? On my little triangle over here that has the same proportions, I have B prime is 5. So B is 10. So what I do is I multiply by 2. And then I'm done, really. A will be 2 times 12 is 24. And C will be 2 times 13, which is 26. This is one way to do it. And as sort of halfway through, I started thinking that maybe I don't even like this way of doing this that much. Okay, I mean, there's other ways to do it. Another way is, let's just maybe call it method 2. That, look, I have B is equal to 10, and it says sine of B is equal to opposite over hypotenuse, so that's going to be B over C, and that's 10 over C, all right? Well, we also have that sine of B is given to be 5 over 13. So putting those two together, we're saying that 10 over C equals 5 over 13, and we cross multiply. I don't know. I don't hear people doing that. I used to learn that when I was in junior high school when we did some beginning algebra. So we have 10 times 13 equals 5 times C. So dividing both sides by 5, 10 times 13 divided by 5 equals C. So that's going to be 2 times 13 is 26. So that's another way. So we already have B is 10 and C is 26. And now we do A squared plus B squared equals C squared. The problem with this is the numbers are actually going to be quite a bit bigger. A squared plus 10 squared equals 26 squared, which I'm just not actually that crazy about doing. I can do 10 squared in my head, but 26 squared, oh my gosh, I mean, that's calculator time, but I guess if I want to rough it, I'll just see if I can do it this way. There's probably some quick way that someone can tell me about to figure this out. 676, A squared is equal to subtracting 576. So therefore, A is equal to 24 when I take the square root. So you could do it that way. I sort of think the first way has a lot of advantages. But the first way, even though it was quicker, might have been a little bit confusing. Okay, let's stop at that for our video.